Hi there. What we're going to work on right now is how to solve compound inequalities. And compound inequalities can be broken into two categories. The and problems, which we will do first, and then of course the or problems. When we're looking at the and problem, what you can see is we actually have the word and right here. So what we do is we solve both of these inequalities individually. Okay, so we're going to add 5 to each side, and then we're going to divide by 3, which leaves us with negative 5/3. I'd like to change that into negative 1 2/3 because we're going to be graphing this on a number line in a minute, and that's going to be easier to find on the number line than negative 5/3. Okay, so now we jump up here to the other inequality. We divide by 2, we divide by 2, and we get x is less than or equal to 2. Okay, so we have two components here. What we have to do is we have to find the set of numbers that work for both of these inequalities. They work for this and that. So if we draw a little number line here, I always like to have 0 on the number line, negative 1 2/3, and then of course 2 would be somewhere over here. And we don't need to make a perfect number line, just something to reference. So let's graph this one first. Okay, it says that negative 1 2/3 is smaller than x. So the first thing is we will have a closed circle here because the fact that it says less than or equal to. And negative 1 2/3 is smaller than this set of numbers over here. Or you could kind of read it the other way and say that x is bigger than negative 1 2/3. Now let's go ahead and let's graph this inequality that says x is less than or equal to 2. Again, because it says equal to, we have a closed point, and x is smaller than 2. So x is these numbers. What we have to do right now is we have to look for the overlap. What numbers satisfy both conditions? Well, it's all of these numbers in here, starting with negative 1 2/3 and going all the way up to 2, and including both of those numbers because they both had a closed dot. Writing the solution to this is very easy because we see that x falls between and includes 2 and negative 1/3. Okay, so that is one way to write your solution. Another way to write it is in what we call interval notation, which basically says we are going from negative 1 2/3 until 2. And because we are including the negative 1 2/3, we put a bracket. And because we are including the 2, we put a bracket. Okay? All right, the next way we can do this is if we have everything in one big inequality here. So what we have to do, kind of like how we balance an equation, where we balance the left and the right, well now we have to balance the left, the right, and the middle. So we need to isolate our x. So we're going to subtract 7 from the middle term, which means we're also subtracting 7 from the left and subtracting 7 from the right. We get negative 28 is less than negative 2x, which is less than 0. And now we're going to divide by negative 2. And again, that means we have to divide everything by negative 2. Remember that when we divide by a negative, we must switch our inequality symbols. So it says 14 is bigger than x is bigger than 0. So let's go ahead and make our number line. We need our number 0. We need our number 14. These inequalities do not have the equal sign under them. So we will have an open circle here on 14. and it says 14 is bigger than x. Well, 14 is bigger than these numbers. And then it says x is bigger than 0. Open circle on 0, and x is bigger than 0. Well, 1, 2, 3, 4, 5, and so on. Those are the numbers that are bigger than 0. So again, we say, where is the overlap? Well, the overlap starts at 0 and ends at 14. But what you'll notice is it does not include 0 because of this open circle, and it does not include 0 because of this open circle. So just like before, we can say x falls between but does not include 0 and 14. And that is interval notation. I'm sorry, that's set builder notation. And interval notation, we would say x goes from 0 to 14. And because we're not including the 0 and 14, we put parentheses. And that's the indication we don't use those. Okay, so solving OR problems, they're very much like solving the AND problem. The only thing is we don't have to look for an overlap. So on the first one, we solve just like we did before, subtract 7, subtract 7. We get x is less than negative 9. It's going to be one part of our answer. And then we have subtract 7, subtract 7. X is greater than negative 5. Okay, we are going to put these on the number line, and we don't need an overlap. So let's see here. X, here we need negative 9, and here we need negative 5. X is less than negative 9, open circle, arrow to the left. X is bigger than negative 5, open circle, arrow to the right. Those are the solutions. Okay, those are the solutions because it's either this or that. And we do not need both conditions to be satisfied. Number 4, same routine. We see the word OR in here. So we're going to solve each of these on its own. So we get 2x is less than or equal to 5. X is less than or equal to, it would have been 5 over 2. I'm going to make it 2.5 for graphing purposes. And then for this one, we're going to add 8 to each side, and we get a solution. X is greater than or equal to 11. So let's get our number line ready. Here's our 0. Here's our 2.5. And here's our 11. X is less than or equal to 2.5. Close circle, arrow to the left. Whoops. X is greater than 11. Greater than or equal to, sorry. Close circle, arrow to the right. We're done. Okay, so hopefully this will help you solve your compound inequalities. Have a great day.